Okay, well, this is part two. Crap. I got interrupted there. So hopefully this, you'll have to bear with me on this. I'm still kind of learning how to do this through YouTube. Anyway, so to make a long story short, lots of math goes into this. So basically, let's say you have, I have a couple of examples. Let's say you have one item, you've got one item you're interested in. One place has a 100% rating, but it's only 10 people. And another place has a 90% rating, but it's 50 people. And another place has a 93% rating and it's 200 people. How can you manipulate those numbers in such a way as to have a usable number that you can use for comparison purposes so that you can look at some index, let's call it, and say, well, you know, this one's a higher number, a higher percentage, and we want to go with that because you can, I'm sure you can already feel in your guts that you know that, 100% with only four people is not going to be accurate. You can, instinctively, I'm sure that the probability of that being accurate is not very good. But 100% with 5,000 people, in your gut that that's, it's very unlikely that the next person will give them a bad rating. This person's really got it on the ball. So, and I'll, just so you can see the output of this equation, here's, let's see if I can, here's what it looks like with some examples. And so you can see that, and I'll show you the equation here in just a second. But you can see that somebody that's got in Amazon, for instance, that's got a 96% rating, and 50 people have rated them. The adjusted percentage that you want to, this is what you want to look at. The adjusted percentage is 94.23%. So that's the one you want to use to compare. And you can see that, for instance, 100%, but only 5 people is only worth 85%, which is actually kind of surprising to me. That's better than I would have thought. But if we drop that down by 1, you can see that now it drops down to 83 and a third percent. And here's some other ones. Here's 100%, but 699 people have rated them. They get a full 99%. So these are the numbers you want to use to compare, and they are based on these two numbers coming in. And the equation to do that, which I'm probably going to create a spreadsheet for, looks like this. So your variables are the seller's rating, such as 96%, the number of reviews, in this case, for instance, 50, the number of positives you don't have to worry about. That's actually calculated. If you want to know the number of positives, it's just simply A times B divided by 100. To get D, which is that corrected percentage that we want to use, this is the equation that you can use. If you only have the number of positives, let's say you're in a website that just tells you that, 50 people out of 100 like this product, instead of saying 50% of 100 people. So you can use this equation. This is one way to get it, which is C plus 1 divided by B plus 2 times 100. So that would give you your corrected. But another way of doing it with the percentage number, which I'm pretty sure that's pretty much how you get it in Amazon. This is the equation here. It's A times B divided by 100 plus 1 divided by B. I should have said A and B. Okay, A is the percentage, like 96%, times B, which in my example up here is 50, divided by 100 plus 1, divided by the 50 again, which is up here, plus 2 times 100. And that's in the example up here, which I'm using 96% is what the person has for their seller rating, and they have 50 reviews. So if you plug those numbers into this equation, and it's not really a complicated equation, you can do it very nicely on a calculator, especially if one has, if the calculator has parentheses. Watch your parentheses, because if you don't put those in correctly, if you do these, you want to do A times B, then divide by 100. You don't want to do A times and the product of, or the quotient of B divided by 100. So the parentheses are a bit important. Anyway, on the example, 96, a 96 rating out of 50 people gives you a realistic or usable percentage of 94.23. That's the number you want to use to compare. You might find somebody else that has, let's say, 98%, but only 40 people, and their usable percent, I'd have to run it through, but their usable percent might be less than 94, and so you don't want to go with them. So this is the number that you want, and this is the equation that spits it out. I'm probably going to consider making a spreadsheet. So because this is something that comes up to me all the time, and I'll see the same item that's available from multiple places. I think I've seen it in eBay, and I think I've seen it in a couple of places, maybe wish.com, I can't remember. So it's a very useful kind of thing. But anyway, this was kind of a fallout from the studying that I did looking at binomial distributions. And I thought, when I study math, I kind of like to try to find a real world problem that I can attack, so that in the back of my mind, as I'm learning, I can sort of say, how would this apply to that particular real world thing? This came up today, as a matter of fact. There's a doctor who has some sort of a cure for the coronavirus, and he's had 100% success rate. If, by success, he means nobody died and nobody was intubated. So he's had 100% of the people he's treated that have not had to go in to be intubated. And he has treated, of the people that needed to go to the hospital, he's treated 699. So the question is, and here that is right here. So he comes out with a 99.86%. So there is a very tiny small chance that the 700th person might have to be intubated and or would die. So what this is telling you is the 100% of 699 people is no guarantee that the next person won't die. What this does tell you, however, is the likelihood that these numbers are something you can rely on. So that's kind of how that goes down. Okay, so there you have it then. All right. Have fun.